Assalamualaikum and greetings. In this video, we're going to take a look at the carboxylic acid derivative. This video will cover the introductory part of the carboxylic acid derivative and also the nomenclature. We're going to discuss the IUPAC name for each of the carboxylic acid derivative. So to begin with, since the carboxylic acid derivative derived from carboxylic acid, so if we have the general formula for carboxylic acid, which are R, C double bond O, OH, we can divide the structure into two sides. So we're going to break down the RC double bond O, a part of the OH, and then we can simply label this as A and also B. So basically, the carboxylic acid derivative will inherit one of the part, which is the part A, which means that the four carboxylic acid derivative is going to have the RC double bond O structure. The second one also have the RC double bond O structure. The third one will also have RC double bond O structure, and finally the fourth one will also have the RC double bond O structure from the carboxylic acid. What makes them different from one another is they are B side. Okay, for the first one, we're going to replace the OH with halogen compound. So in general, we write it as an X. So it can be either fluorine, bromine, chlorine, iodine, or also acetylene. The second one, we're going to replace the OH with O, C double bond O, R. The third one is R, C double bond O, O, R, which R is the alkyl group, yeah. And then finally we have the last one, the OH will be replaced with N. The R1 and R2 can be either carbon or it can also be hydrogen. Therefore, the name of every derivative is as follows. The first one is also known as acyl halide. Sometimes it is being called as acid halide since it is a derivative from the carboxylic acid. The second one is also known as acid anhydride, or we just simply write anhydride to it. The third one is ester, and finally the last one will be amide. Okay, do not confuse the amide with amine. The difference between them is one is from the carboxylic acid while the other one is basically alkali. So for amide, we also have the C double bond O structure, whereas for amine, we don't have the C double bond O structure. So this is the general formula for all of the carboxylic acid derivative. Again, they're going to inherit the RC double bond O structure from the original carboxylic acid, and then the B side, we're going to replace it with another compound. Now let's take a look at the nomenclature. The name for carboxylic acid derivative is originated from the carboxylic acid itself. So basically, for any carboxylic acid compound, the name will end up as oic acid. For instance, if we have 4 carbon of a carboxylic acid, it will be called as butanoic acid. So for an acid halide, instead of naming it as oic acid, we're going to change the oic acid into oil and then the halide. So for instance, if we are using chlorine, it will become chloride. If we are having bromine, it will become bromide. Iodine will become iodide, and so on. So let's take a look at one of the examples. Basically, if you have a structure like this, in this case, okay, the number 1 will belong in the C double bond O. So the longest chain will be 6. and this is carboxylic acid. The name will become hexanoic acid. Now, if we replace the OH with something else, with a halogen, let's say we're going to replace it with a chlorine. Therefore, we're going to change the OE acid into the oil halide compound. So the name will become hexanoyl chloride. In another example, if we have an aromatic acyl halide, so it is originated from benzoic acid. So benzoic acid is a benzene attached to the C double bond O OH. This will be benzoic acid. If we want to convert the benzoic acid into an acyl halide, so we just simply replace the OH with any halogen. In this case, we're going to use bromine. So again, we're going to replace the OE acid into oil halide. So this will become benzoyl bromide. Please take note, the I and E, we're going to replace it with IDE for the halogen compound. To make the structure more complicated, okay, we just might want to add a few substituents to it. Okay, for instance, let's add substituents such as the isopropyl, and of course we can also have OH group from the alcohol, and perhaps some halogen. Let's put Br to this. In my previous lecture, I always highlighted that we need to consider two things before we decide on the IUPAC name of the compound. Take a look at the main functional group or homolog series present in the structure so that we can come up with the parent name. The second one, we need to determine what is the longest continuous carbon that we can come up with. Okay, in this example, we have the functional group of the acyl halide, alcohol, halogen, and also a simple isopropyl as the substituent. So in this case, we know that the acyl halide will have the highest priority since it is from the carboxylic acid derivative, although we have bromine as the alkyl halide and so also the hydroxide from alcohol, both of them having lower priority compared to the acyl halide compound. So if we do the numbering, the first carbon will belong here, second carbon will be here, third carbon, fourth carbon, fifth carbon, and also the sixth carbon. So guys, the longest chain is 6, therefore the parent name will be hexanoyl chloride. And don't forget to list down every substituent that we have. Okay, we have 3 hydroxyl, 5 bromo, and also 4 isopropyl, and they need to be arranged in alphabetical order. Therefore, the first one will be 5 bromo, followed by 3 hydroxy, and then we also have 4 isopropyl hexanoyl chloride. So this will be the correct IUPAC name for the structure. The example for an aromatic acyl halides. Let's say we have a benzene ring attached to the C double bond O, and of course it need to attach to a halogen. In this case, we take the bromine, and we can simply add other compounds such as CHO and H2, and perhaps we have a methyl group there. Right, we're going to use the same approach. First, we need to determine what is the main functional group. In this case, although we have amine, we have aldehyde, and also we have acyl halide, the acyl halide will become the parent since it has the highest priority compared to the aldehyde of the CHO and also the amine from the NH2 structure. Therefore, let's come up with the parent name. This will become the parent, and then of course we're going to start the numbering here for the aromatic ring, and we're going to number it anti-clockwise since it will give the lowest number for the location of the substituent. So let's write down the parent name first. It is benzoyl bromide, and of course we're going to list every substituent that we encounter. We're going to start off with amino, which is located at carbon number 4. Then we have the formyl, which is represented by the CHO. So this will become 2-formyl. And finally, we have 5-methyl. Again, we're going to arrange them based on the alphabetical order. So the name will end up as 4-amino, 2-formyl, 5-methyl, benzoyl bromide. Next is the IUPAC name for acid anhydride. But before that, we should be able to distinguish between the symmetrical and also unsymmetrical anhydride before we assign the IUPAC name for it. If we take a look at the structure of acid anhydride, it will be like this: R, C double bond O, O, C double bond O, R. So there are two types of acid anhydride. The first one, we call it as a symmetrical anhydride, while the other one is unsymmetrical anhydride. How to distinguish between them is, let's say if we divide the structure into two sides, we can have like a mirror image between each other. So let's say if the R over here has the same number of carbon and also it has the same structure just like the red R, so we consider them as symmetrical. Otherwise, if the black R and also the red R having different number of carbon, and if the number of the carbon is the same, however the structure is different, we're going to call this as unsymmetrical anhydride. So again, it is originated from the carboxylic acid compound. For carboxylic acid, it's going to end up as acid. For anhydride, we're going to retain the oic sound. However, we replace the acid into anhydride. So let's say if one side we're having 4 carbon attached to the oxygen and then attached to another series of 4 carbon chain, this will be considered as a symmetrical anhydride. As you can see, the number of carbon and also the structure for both sides is the same. Therefore, this is a symmetrical anhydride. So in order to name a symmetrical anhydride, we're going to number them, start from the C double bond O. So in this case, we have 4 carbon. Same goes with the other side. We also have 4 carbon. So technically, if this was a carboxylic acid, it will be called as butanoic acid. However, in this structure, we realize that this is an anhydride. Instead of using acid, we're going to replace it with butanoic anhydride. Please take note that instead of writing as butanoic anhydride or dibutanoic anhydride, we're only going to use only one butanoic anhydride. We're using this because it is a symmetrical anhydride. So whenever we mention anhydride, please make sure that it has a C double bond O or C double bond O structure attached to it. Again, this naming is only applicable for symmetrical anhydride. For an aromatic examples, if we start from a benzoic acid, it will be looking like this. Okay, the compound name is benzoic acid. However, if we replace the OH with O, C double bond O, and also the benzene, first we need to determine whether it is symmetrical or unsymmetrical anhydride. So in this case, it is symmetrical since it has the same number of carbon and also the structure is also the same. Instead of the benzoic acid, we're going to replace the acid with an anhydride. What about unsymmetrical anhydride? So the idea is if the two sides of the anhydride having different number of carbon or they have a different structure, it will be considered as unsymmetrical. So for instance, if we have the structure of 3 carbon attached to the oxygen, and then it attached to the C double bond O, and it attached to the aromatic ring. In this case, we simply knew that this will be an unsymmetrical anhydride because it has a different structure and different number of carbon at both sides of the anhydride. The name will end up as anhydride. This time around, since it is not symmetrical, we're going to mention both sides of the structure. For this side, it has 3 carbon, while the other side, including the C double bond O, it will be called as benzoic. Therefore, this will become benzoic propanoic anhydride. And of course, in order to make the structure more complicated, what we can do is we're going to add substituent to it. So we're going to have our anhydride structure, which is C double bond O, O, C double bond O, and then we just add a few carbons there. For this side, I would like to add a longer chain of carbon. And then after that, I'm going to add substituents such as the methyl group. This one, I would like to add the bromine compound. So again, we knew simply that this will be unsymmetrical anhydride. Therefore, we're going to mention both sides of the structure. But before we do that, of course, don't forget to number the compound first. This will be the first carbon, second carbon, third carbon, fourth carbon, and overall it is 6 carbon. For this one, it's only having 3 carbon, and then there is a bromine attached to the third carbon of it. So guys, the first thing that you need to do is we need to list down every side of it, but you should already know that the name for this compound will end up as anhydride. The structure over here. So 3 carbon we call as propanoic. And then we have the substituent at the third carbon, therefore it becomes 3 bromopropanoic. Okay, for the other side, we have 6 carbon, so this will become hexanoic. And then we have the substituent at carbon number 3 and 4 of the methyl group. Therefore, this will become 3,4-dimethyl. Therefore, guys, there you have it. The name will be 3,4-dimethyl hexanoic, 3-bromopropanoic anhydride. It has 3 separate words to describe the IUPAC name of the respective compound. Okay, now let's move on to the IUPAC naming for ester. Ester is represented by the general formula of R, C double bond O, OR, whereby the R represents alkyl group or carbon-carbon chain. So basically, there are 2 parts of the structure. The first one is the carboxylic acid, which is represented by the RC double bond O structure, while we have another one of OR, which is representing the alcohol part. So basically, if we have a carboxylic acid reacting with the alcohol, it's going to produce the ester, just like the experiment that we did in the synthesis of isopentyl acetate, the banana oil. The name of the ester is originated from the carboxylic acid, where for the carboxylic acid, it will end up as oic acid. So for an ester, we're going to replace the oic acid into OATE, which represent the carboxylic acid part. And then for the alcohol part, we're going to name this as an alkyl attachment, depending on the structure and the number of carbon which is represented by this R. For instance, if there is only 1 carbon, it will become methyl. If 2 carbon, it will become ethyl. 3 carbon will become propyl, and so on. And of course, if the R is representing by this structure will be known as isopropyl, since it is having 3 carbon attached to it, and then the attachment of the O attached to the second carbon. That's why we name it as the isopropyl structure. If we have this compound, what we need to do first is we need to identify which part is the carboxylic acid part, which part is the alcohol part. So basically, the structure which have the C double bond O will be considered as the carboxylic acid region. So again, the first carbon will belong to the C double bond O, followed by number 2 and number 3. So 3 carbon, we're going to replace it from oic acid to OATE. It will become propanoate. For the alcohol part, is starting from the attachment of the carbon to the oxygen. So this will be the first carbon and the second carbon. Therefore, 2 carbon as the alkyl attachment will be called as ethyl. So the name for the ester consists of 2 words, ethyl propanoate. Again, ethyl representing the alcohol part, while propanoate representing the carboxylic acid part. In another example, let's say we're dealing with the aromatic ester. So let's say we have a benzene attached to the C double bond O. If this was attached to OH, this becomes benzoic acid. However, we're going to modify this a little bit. We're going to replace it with oxygen, followed by the alkyl group. So again, we need to identify which part is the carboxylic acid part and which part is the alcohol part. So this will be the carboxylic acid part, while the 3 carbon belongs to the alcohol part. So let's try to name this first. From benzoic acid, change the name into OH, benzoate, while this part a 3 carbon, therefore it will become isopropyl. So the name for the compound is isopropyl benzoate. Just like the previous carboxylic acid derivative, whether it is acyl halide or acid anhydride, to make the structure more complicated, we're going to add a few substituents to it. Okay, for instance, for the aliphatic chain, let's add 2 methyl group to it, and let's try to add halogen to this. So again guys, you need to make sure that you should be able to identify which part is the carboxylic acid and also which part is alcohol. Again, all of the carboxylic acid part must consist of the C double bond O. So let's number this first. Number 2, number 3, and also number 4. Therefore, the name will become butanoate. And as you can see, there are some substituents attached to it. There are 2 methyl group and also 1 chlorine group. The name will be looking like this: 3 chloro 2 dimethyl butanoate. This name only representing the carboxylic acid part. So what about the alcohol part? Okay, benzene as a substituent will be named as phenyl. Okay, not benzene, not phenol. Okay, it will be called as phenyl because we're going to take this as an alkyl attachment to the ester compound. So again, there will be 2 sides of the name. The first one representing the alcohol part, the second one representing the carboxylic acid part. And finally, the IUPAC name for amide. So guys, the general formula for amide is RC double bond O and attached to the nitrogen. And the nitrogen should have 3 bonds. So I'm just going to label it as R1 and also R2. The R1 and R2 can either be carbon chain or it can also be hydrogen. So just like the previous carboxylic acid derivative, all of the name is originated from carboxylic acid, which end up as oic acid. If we convert the B part of the carboxylic acid into an amide, so the oic acid will be replaced with amide. For instance, if we have 5 carbon of amide compound, we have C double bond O and then it attached to the NH2. The first thing that we need to do is we need to determine the longest chain. In this case, we have 5, which start from the C double bond O, followed by number 2, number 3, number 4, and number 5. If this was a carboxylic acid, the name will become pentanoic acid. However, we have changed the OH structure into NH2, so this will become pentane, and then just simply add amide at the back. So the oic acid will be replaced with amide. So this will become pentanamide. If we have an aromatic amide, it is originated from benzoic acid. The benzoic acid will have the OH attached to the C double bond O. However, we're going to replace the OH with NH2. Instead of having benzoic acid as a name, what we're going to do is we're going to omit the oic acid and then we're going to replace it with amide, so that it becomes benzamide. To make the structure more complicated, what we can do is we're going to add another substituent to the structure. So for instance, if we have this compound, we might want to add some alkyl group, or you can also add NH2, or we can add another compound to the structure. So in this case, the parent name is pentanamide. In the same time, we have the substituent located at the third carbon and also the fourth carbon of the parent chain. So the fourth is amino, while at the third carbon we have the ethyl group. Again, the name should be arranged based on the alphabetical order. So we have 4-amino, 3-ethyl pentanamide. Another substituent that we can have is at the NH2 of the amide compound. Let's say we have an aromatic amide, and then attached to the C double bond O, which attached to the nitrogen. Again, the nitrogen should have 3 bonds, so instead of having hydrogen attached to it, we're going to replace it with a methyl group, and then we can also add an ethyl group attached to it. So in this case, to differentiate the substituent which attached to the parent chain compared to the substituent attached to the nitrogen, all of the substituent which attached to the nitrogen will be having a prefix of N in front of the name. For instance, since we have N-ethyl and also N-methyl, what we're going to do is we're going to write it just like when we write numbers for the substituent. So in this case, this will become N-ethyl, and we have also N-ethyl, to indicate that the substituent is located on the nitrogen atom of the amide compound. So don't forget the parent name. The parent name is from the benzoic acid, so it will become benzamide. Again, I would like to highlight that if the substituent is attached to the nitrogen, we need to use the prefix of the N. If the substituent is located on a parent chain, that's why we're going to use numbers. So this will conclude the IUPAC naming system for the carboxylic acid derivative. In summary, the name for carboxylic acid derivative is derived from the carboxylic acid, which end up with oic acid. So if it is an acyl halide, it will end up as oil halide. If this is for acid anhydride, the oic will remain while the acid will be replaced with anhydride. Please make sure you already identify whether it is symmetrical or unsymmetrical anhydride. If it is symmetrical, you only need to mention it once, but if it is unsymmetrical, you need to mention both sides of the anhydride compound. For ester, the oic acid name will be replaced with OID, while the alcohol which attached to it will be named as the alkyl attachment. And finally, when we have amide, the oic acid will be replaced with the amide at the back. That's all for the content for this video. Please leave any comment in order to improve the presentation of this video. Thank you for watching.